Ladies and gentlemen, meet Bob. Bob is a nobody. He has no friends, he has no pets, he has nothing. Well, one day when Bob was wandering through the desert, he met a dog. But this dog wouldn't talk to him, wouldn't play with him. Bob couldn't do anything with the dog. Even offering an iguana on a stick to the dog wouldn't get the dog to follow him. Well, this is Fallout 2, and this is a Fallout 2 modding video, so let's fix that. There's actually a pretty simple way to do this. Let's make a script where our new dog friend will follow Bob around the map. First of all, I'm going to use the Sfall Script Editor. You can use Notepad or whatever you want, but I like the Sfall Script Editor. Works perfectly well for what we're doing. Go to the New dropdown. Quick warning here. Don't click New by itself. If you create a new script by clicking the New button, then you try to hit Compile, it'll throw an error even if there's nothing wrong with it. This is just a bug in the Sfall Script Editor, so bear that in mind when creating new scripts. Instead, click the New dropdown and go to Critters. Now, if you've been messing around with this a little bit, you'll kind of have a basic understanding of what's going on here. For today, though, this is a very simple scripting tutorial. So I'm just going to delete all of this stuff. I don't need anything advanced right now. I'm just going to delete all this stuff. Don't need it. Anything with a red line under it, delete it. And then we're going to save this file with a new name. We're going to call it meatdog. For no good reason. There we go. We have a new meatdog.ssl script all ready to start putting commands into. The very simple script that I'm going to start with today is one that will have meatdog following Bob around the map. As a model, for those of you who are new to scripting, I'm going to open up Dogmeat script, which for Fallout 2 you will find in the random encounter folder under EC Dogmeat. Right inside the critter Preproc procedure is where all the Dogmeat stuff happens. And if you scroll down, the only section we really need to pay attention to is this one right here, where it says, if not local variable LVAR hostile, then begin Dogmeat and party, then begin party member follow dude. Now, this is one method of following the player. This one applies if the character is in the party already. This is also a more advanced one, which I will cover in more detail when I make my party member video with a lot more information. But I do go over it briefly in the latter half of this video. There should be a timestamp at the bottom of the screen if you want to jump to it. Now, this is a much simpler script, and it's the one we're going to start off with. End else if local variable LVAR used iguana, then begin follow dude 1-3. You can, if you want, just copy and paste this into meatdog's critter pproc and remove the end and the else, and then add another end. And we don't need these extra 3 spaces either. And now you'll notice this has a big red squiggly line under it, and the red line is Sfall's indicator for a bug or an error in the script. This one says undefined symbol LVAR used iguana in factor. But really, this is just a method of checking to see if the player has done something before having meatdog follow Bob. So we can just delete this one as well. Remove the end here as well. And now we have just follow dude 1-3. And we can compile this. Now that we have our script compiled with no errors, go ahead and shrink this down and open your mapper up. Open the map where you have the meatdog character saved. Press F2 to select the critter's arc category, otherwise you won't be able to select meatdog. Highlight meatdog. The easiest way is to just click on him and you can see a little red hex under him. You can also press the M key to change it to an arrow. Sometimes it makes this a little easier to select and move around. Highlight meatdog. Go down here to the bottom left where it says edit. You can click the edit button, or you can hit E to edit as well. They both do exactly the same thing. There's a little new script button in the window that pops up. Click this button and go ahead and find meatdog.int in this list. You can search it by pressing the M key and then scrolling down with the arrow keys or the page up, page down keys. The mouse scroll wheel does not work in this version of the mapper. Well, here's meatdog. Click it. Meatdog.int is the new script. Click done. If you press I, you can actually see the script name directly above the critter it's attached to. One little warning here, the mapper only shows the first 20 scripts on the screen. The rest are still there, but you'll have to isolate them somehow if you want to see them. Meatdog is attached to meatdog, and Bob1 is attached to Bob. I'll get into Bob1's script later. For now, this is all you need to do. When you're done attaching that script, go ahead and go to File, Save. Bob.map is saved. You can Alt-Tab or escape and exit, however you want to do it. If you don't already have it up, open your Fallout 2 mod folder, and from there, open the ddraw.ini file inside it. You can scroll down until you find the starting map listing, or you can press Ctrl F and just type starting map right there. Now, I have my starting map set to bob.map. This is the name of my map. Change it to match the name of your map that you want to start out on. Save it. Close it. and then start the game up. Start a new game. Take the default character if you want, just to test. And as you can see, Meat Dog is following Bob. I'm using a special script that actually allows me to control Bob, and in this case, Meat Dog is technically following the player character because of this script. I actually have a short video explaining this advanced command, and a link and timestamp will be in the description. For now, let's go back and take a look at Meat Dog's script. This command, followDude13, is actually a macro, and you can see what the macro requires and a written definition of what it does in this little Intellisense pop-up that happens when you hover the mouse over the command. If you right-click on it and you select Go to Declaration right there, it will actually open the command.h file where the macro is declared. And this is the entire macro right here. If you take a closer look at this macro, it uses other macros inside of it. Current distance from dude, future distance from dude, and then animate run to tile, and animate move to tile as well. This is a good way to learn how to script in Follow 2, and really it's just about the only way right now. There are a few ancient wiki articles and a bunch of esoteric discussions hidden away in forums, but nothing nearly as comprehensive as just looking at the game's source scripts for a better understanding of Fallout's scripting language. Except maybe learning to program in C and Pascal, the two languages the Star Trek scripting language, the scripting language used by many of Interplay's games, including this one, is based on. The easiest way to do this is to right-click on any of the macros and select Go to Declaration. This will take you directly to the definition, and you can actually look at how the definition is written to figure out how to script yourself. I found this very helpful myself when learning how to script. I still had to ask for help on occasion, but the anime forums are a fairly welcoming place for new modders, although you should keep your questions simple and specific until you have a solid grasp of the basics. Oh, and always ask for example scripts. Modders love to show off their work, especially for the newer, more advanced Sfall features. Still, as a beginner, this is a good practice to start. Any chance you get, go in and take a look at what the macro looks like and how it's written. Now, this macro uses, at its simplest form, 3 different other macros. Current distance from dude, future distance from dude, and animate run to tile. If you right-click current distance from dude and click Go to Declaration, you'll notice that it's actually not that far above the current entry. Here's follow dude we were looking at, and here's current distance from dude. Now, current distance from dude uses actual commands: tile distance objects, self object, dude object. Now, dude object always refers to the player character, and as I said earlier, I used a special script to give the player control of Bob. Go check out that video to find out how it works. For now, dude object and future distance from object both point to the tile number and direction. One of the advantages of having a predefined scripting language is that many scripts are almost understandable when read aloud. For instance, when reading this macro, tile num and direction, tile num x has trait object x, object current rotation +3 modulo 6, you can almost make out that we're looking for a tile number in a certain direction from something with the object trait and rotation. Now this +3 modulo 6, when I first looked at this confused me. So this is always a good practice to do as well. If you find a confusing piece of code, do not be afraid to walk through it and figure out how it works. So we're going to walk through this piece of code really quick to understand how it works and hopefully give you a tip for your future mods. This one command right here has trait object, meaning it's an object as opposed to a regular trait like gifted or jinxed. If you right click on here and you go to declaration, you'll notice all it is a trait defines trait object is 1. You may also notice the scripter opens up defineLight.h, which does have the defines I'm looking for, but this is still the wrong header file. If you go back to your base script and open the define.h, which is included here, and search for trait object, you'll find the same information defined here. You can see above and below this that trait perk is 0 and trait is 2. If you've had experience with programming in C, you'll probably already know this, but all that #define does is replace the first text with the second text in your code. So all this does is, internally, the game uses numbers to identify what element you want to modify. But because numbers are difficult to read in code, this define makes it easy to just use words and swap out the numbers when the script is compiled. A define is what's known as a preprocessor directive. Feel free to Google that if you need more information. So that's what trait object is, and the same thing applies to object current rotation. If you go to declaration for this, it's also defined as a number. And finally, x. In this case, x is the object pointer for dude object. So this would be passed into here as x, and that'll be passed into here and here. Then we have object current rotation. Now this is where it starts getting important. Object current rotation is the trait that we're actually trying to find. So if you take a look at the description for has trait, it is int has trait. Inside that is int trait type, which is trait object in this case. Object pointer who, which is x, and in this case, dude object is being passed into it. So what will be returned is the object current rotation, which is the trait we're looking for. Now the object current rotation is a number that ranges from 0 to 5. And if you open your mapper on the bottom corner of the mapper, you can actually see that. And if you click the up and down arrow keys, you will see immediately they go from 0 to 1 to 2, 3, 4, and 5. So those are all the directions, and then back up to 0 again. So to make this simpler to understand, let's go ahead and number the directions. As you can see, this arrow is pointing at 0. So this is what we're looking at for the notation that's going to be passed into our script from the engine when we call hasTrait, and then are looking for the object current rotation 0, 1, 2, 3, 4, or 5. But then we add 3 to it. Now, if you add 3 to this number, let's say we start at 0, we add 3, 1, 2, 3. Then it'll be facing the exact opposite direction of the player character, of the dude object, or of whatever critter object that is being referenced here. Problem is, if you add 3 here, 4, 5, 6, there is no 6. Instead, it starts over again at 0. The same thing applies to 4, 5, 6, 7, there's no 7, and 5, 6, 7, 8, there is no 8. So there's no 6, 7, or 8. So how do you get these back into line so they're once again between 0 and 5? Well, that's where the modulo 6 comes in. Now, I did not know this when I first started scripting, but any number less than a divisor when using modulo actually returns itself. Wait. Let me back up for a second and talk about modulus. The modulus operator returns the remainder of one number divided by another number. Remember in grade school when you were taught how to do division with this funny little right angle line and the divisor in front and the dividend inside? And above this line, you would write how many times the divisor would fit into the dividend. And then, just to the right of this, if there was any, you'd write what was left over and call it the remainder. Well, modulus just returns what's left over, the remainder. So back to what I was saying, any number less than a divisor will always have a remainder of itself, which is what modulus will return. Thus, 1 modulo 6 is 1. The same thing applies to 2 modulo 6 returns 2, 3 modulo 6 returns 3, and as you can see, everything from 1 to 5 returns the original number. But once you get to 6 modulo 6, that's when it starts over at 0. And 7 modulo 6 begins at 1 again, 8 modulo 6 is 2, and 9 modulo 6 is 3. Not that we'll ever get to 9 in this function. This is one of those little programming tricks you may end up using quite a bit depending on the kinds of problems you have to solve, and that is how modulo works. And that little trick is being used to keep the number itself rotating from 0 to 5 without actually going above 5 and producing an error, but still return the number representing the direction opposite of the direction the character is facing. And the last entry here, y. If we hover our mouse over the tile num and direction command and look at the Intellisense, int start tile is the first argument. Tile number x, which is the tile number for the dude object, 0 to 5 direction, which once again is this entire command here which says hasTrait, trait object, x, object current rotation, plus 3 modulo 6. This entire command here is the second entry. It returns 0 to 5, which is the direction that in this case is pointing behind the character y distance. In this case, y is passed through from the original command follow dude xy right here. So what future distance from dude does is locate a tile directly behind the dude object at a distance of y hexes. Now current distance from dude, if we right click this and select go to declaration, is right above future distance from dude. And current distance from dude is a very simple one. Tile distance objects, self object, dude object. Self object is always the object that the script itself is attached to, which in this case would be meat dog, or whatever critter you've placed on the map. And dude object is always the player character. So all this is a simple calculation that tells the game the distance between the two objects. So now that we know how current distance from dude works and how future distance from dude works, let's go ahead and take a look at the entire macro. If current distance from dude is greater than x, then begin. So x is the first number that was passed in here, and if you'll recall, x was 1. So according to the first part of this macro, if the current distance from dude is greater than 1, then begin the next part. If current distance from dude is greater than x times 2, which is 1 times 2 in this case, which would just be 2, then begin the next part. Animate run to tile future distance from dude, y. And future distance from dude, as we just looked at, is the tile number directly behind the player character at a distance of y hexes. And y is by default 3 here in the Dogmeat script that we copied over. So in this part of the command right here, if meatdog or dogmeat are greater than x times 2 or 2 hexes away from the player, then it will animate run to tile 3 hexes behind the player. End else begin, in this case, if the current distance from dude is greater than x but not greater than x times 2, they will animate move to tile future distance from dude and then stop. I'll leave the other macros for you to figure out. I'm hoping this explanation is clear enough to get you started in the right direction. Now, this animate run to tile, animate move to tile, animate run to tile force, these are all yellow, whereas this one is a slightly more orange color. Tile distance objects, tile number in direction, rotation to tile. These orange ones are actual base commands. The yellow ones are other macros that have been created from those commands. And if you actually right click on them, you can also go to declaration on these, and this will open up animcommand.h, which you can now take a look at and look at the actual commands they use. Animate move object to tile, self object, x, which was pulled from the future distance from dude macro, which we looked at earlier, and then animate run, or animate move to tile, which is right above it, which is animate walk. And if you right click on here, you can also go to declaration, and then up here, animate walk is 0 and animate run is 1. So this is the most detailed breakdown that I could give of how the entire system actually works. You can actually see, if you consistently right click on commands and select go to declaration, you'll actually start to get an idea of how the individual scripting system works. These are all the header files and also part of the scripts that I had you copy over from the initial install video. If you scroll up to the top of MeatDog, you'll see that define.h and command.h are actually the only two included as far as header files. But animcommand.h was one of the header files opened up when we were digging through the code. Thankfully, you don't actually have to worry about including many of the header files you'll use, because if you open the define.h header file, you'll also see animcommand.h included inside this header file along with a list of others. Okay, back to the script. That is one way of having the critter follow player character around, but if we take another look at our Dogmeat script, you'll see that besides setting the critter as a party member or using follow dude, there is a third way they have set up, which is a basic animation script. So let's go and copy this over to our MeatDog script. We can comment this out by pressing Control and slash, or if you want, you can actually just go straight to the front of it and press //. Or you could also /* and at the end of it, */. That is also a comment line. However you want to do it is fine. I prefer the former because I can just press Control / and it'll uncomment it for me. When you got some space here, right click and go to paste. And now we're going to take a look at this script. Let's go ahead and compile it. Let's see, does it even compile? It does not compile. The reason it does not compile, you can see right here, undefined symbol, doWalking, and factor. It's because doWalking is a variable that is not actually being stored in our script. Now, there's a couple places you can declare your variables. You can declare your variables outside of the critter pproc if you want, but it's not 100% necessary. If you declare a variable inside the critter pproc, it will not be accessible outside of critter pproc if you want to use this variable in other procedures. However, in this instance, that's not something we're going to worry about so much yet. So to declare a variable, you just type the word variable, and then we type doWalking, the name of the variable. We end it with a semicolon, and right away you'll see that the red squiggly lines have disappeared and the error is gone. Now this one is a bit simpler. Let's take a look at how it works. If game time is greater than doWalking, so doWalking is a counter of some sort, then begin. Reg anim clear self object. Now, if you've taken the time to read through the Mapper Editor Introduction, which is inside the Mapper install folder under the Documents section, you'll notice there's a whole animate section that has a whole bunch of animate commands. That's not absolutely necessary for what we're doing today. You can take a look at those, and you should take a look at those and read how they work. But for now, if you right click here and go to declaration, you'll see all three of these lined up in a row. Reg animate begin, reg animate clear, and reg animate end. I'm not going to go too deep into this one this time. We've already had one big sidetrack into how a function works. So the reg animate begin starts the animation process. Animate move the tile should be obvious. It's just a macro that moves the critter to whatever tile you want to point it to. This looks for int tile, so it only looks for a single tile number. Tile num in direction. This is the tile that we're actually going to try and find. If you hover over tile number in direction, you can see that tile number in direction looks for the int start tile first, which is the start tile for dude object in this case. 0 to 5 is the direction. Now, what this script uses is random 0 to 5. Instead of looking for the trait and then adding 3 and using a modulo 6 as future distance from dude does, instead this just generates a random direction. And then int distance, which is the distance away from the start tile, which is also random. This one's 5 to 10. So if you use this command, the tile that Dogmeat will move to is actually a random tile that is a random direction around the player that is a random distance between 5 and 10 hexes away from the start tile, which is dude object right now. I'm going to come back to that dude object in a second. Let me show you the rest of this first. And finally, there's a reg anim end command. Here, doWalking itself is defined as game time plus game ticks, where game time is the current game time when this command is called, and game ticks converts seconds to game ticks, which is basically 10 ticks per second. There's a little bit more to game ticks, and as you can see, it's orange, so it's one of the basic commands available. But how game ticks or game time works isn't the point of this video, but if you skip to this timestamp, I have a little more detail on them. So doWalking stores the time point in the future when this command will be run. And if game time is greater than doWalking, which is basically a timer, then begin reganim clear self object. Reganim begin, animate move to tile. So this little if statement here actually prevents MeatDog or Dogmeat, either one, from moving until a certain amount of time has passed. There's a reason for this, and I will show you in just a minute. For now, let's go ahead and save and compile this script and take a look at what it does. Now, there is a bug in here. However, if you go to compile, it'll compile successfully. The result, however, is that MeatDog is not following me immediately. In fact, MeatDog isn't actually following me at all. You can see MeatDog twitch like he wants to move, but he never actually does move. Now, there's a game tick counter that's between 10 and 40, so I will wait the full 40 seconds here to see what turns up, and I'll just play this in fast forward as well so you can see the entire thing while I finish talking. Unfortunately, MeatDog will just stand there, and in fact, in the original Fallout 2, Dogmeat just stands there as well. Specifically, he's supposed to be following you around the Cafe of Broken Dreams, but he does not in vanilla Fallout 2 because this bug was part of the original script. Whenever you're looking at the vanilla Fallout scripts, you have to remember that a lot of them still have bugs in them. This is something that I was not aware of when I first created my install instructions. However, since there are updated 1.02d source codes as well as the restoration project source codes included with the mapper by default under the updated source codes folder, you should definitely consider checking them when looking for examples of source code for your project. But for some reason, this bug is the same in all three versions, so let's move on. Okay, now that we've established that that doesn't work, let's take a look at what the problem is. Now, what tile num and direction needs is a number that represents where on the map the player character is standing. But doObject is an object pointer, one that specifically points to the player character, not the tile under it. I wanted to have a little explanation on pointers here, but apparently the Star Trek scripting language doesn't have pointers the same way the C language does. Instead, an object pointer here is just a reference to an item or a critter on a map. There are a couple of ways of getting an object pointer. The two most common are simply calling doObject and self-object. I'm still new to a lot of programming terminology as well, so don't feel alone if it's starting to get a little confusing. It's confusing for me, and there's a lot of stuff that I'm trying to explain in this one video. For instance, I like to have a list of commands that return object pointers. That'd be really nice so that I can actually use those object pointers, but that's not so easy to come by, but here's the list I've got so far. Now, this might be obvious for some, but I'll show you the quick fix for this bug. It's tile num and then parentheses around the object pointer, so tile num of doObject. Tile num, if you hover the mouse over it, takes an object pointer object. You see that? In this case, we're going to use tile num to get the actual tile number we need for the doObject object pointer, and then we can run the calculations to determine the random direction and the random distance. So save this, compile it successfully, and then let's go ahead and run the game. Well, we fixed one problem. MeatDog now faces Bob correctly, but he keeps tweaking out and resetting the direction he faces and never actually moves out of his spot. Well, back to the script and let's take a look at the problem where the doWalking variable is declared. The fix is really simple. Just move the variable declaration outside the function and make it a global declaration. The reason we need to do this is because of something called variable scope. If you're unfamiliar with variable scope, you should definitely look it up for more details, but the gist of it is this. When a variable is declared inside a function, or in this case a procedure, it basically lives between the walls of this begin and this end. There are ways to pass this variable to other procedures, but they can't see it without a special call method. However, everything inside this begin and end statement can see this variable and are able to use it directly. But if the variable were to move outside and above these begin and end walls, like walking outside its house into the street, then all the other procedures can now see this variable and use it directly themselves. Meow. There's actually a spot at the top of all script templates that's marked for local variable declaration, so you can, and probably should, just move it out here to easily find later, and to allow all procedures to access it. However, we're not moving it out here for its accessibility, we're moving doWalking out here because each time a procedure runs, and in this case critter Preproc runs every game tick, or 10 times a second. Each time the procedure runs with the variable declaration inside it, the variable is redeclared and reset. Because the procedure redeclares the variable 10 times a second, the walk animation never gets a chance to even start. Incidentally, because the critter Preproc runs every game tick, it's colloquially called the heartbeat of the critter. Anyway, save this script, compile it, and let's give this another try. Start, take a new character, and now MeatDog will follow randomly around my character with a delay. I'm going to go ahead and fast forward this for you, but there you go. You can see MeatDog in this case following me just like Dogmeat would if he was programmed correctly in the vanilla games. Now in Fallout 2, Dogmeat is only supposed to follow this command if the other two conditions are not met, being a party member or you use the iguana on him. Remember, this is not Fallout 1, which had a couple of other options like wearing the leather jacket. This is from Fallout 2, where this Dogmeat is the Dogmeat that's in the Cafe of Broken Dreams. And this Dogmeat is supposed to, by default, follow you around the Cafe of Broken Dreams using this method before he joins your party. But if you've ever been to the Cafe of Broken Dreams, you, like anybody else who's played the games, know that Dogmeat does not move. He just sits there. It's really too bad. Would have been a fun little script to set the scene. If you want to have another example, though, we can also pull up Laddie's script, which does work correctly, and Bess's script. Now, for those of you who may remember, Bess and Laddie and MODOK both did similar things. They would follow the player around the map. They would also follow the player from one map to another. But if we open up Laddie's script, we can take a look and we can immediately see they're using party member follow dude, which is a little more difficult to implement. And the same thing for Bess. If we look at Bess, she also has a party member follow dude command. Now, the party member follow dude command is an interesting one, and let's take a look at it real quick. We'll open Dogmeat's actual script, and let's copy over the party member follow dude section into our critter pproc and comment out what we were working on before. So the first command is, if not local variable LVAR hostile, then begin. Well, we can remove this one since right now I'm not going to worry about whether or not the character is hostile to me. And the next one, if Dogmeat in party, then begin party member follow dude. Now this one does require some work. I'm going to run you through this once just so you get an idea how it works. And eventually I'll have a video covering how to make a full party member so that you can build them yourself anytime. Until then, as you can see right here, there is a big red squiggly line saying there's a whole bunch of errors in here. And that's because we need to declare a whole bunch of LVAR local variables up here before we can actually get this to work. Okay, to track down these problems, let's take a look at Dogmeat and party first. Technically, we could just delete this line like earlier and just use party member follow dude, but there are a couple of party member scripting details I'm going to try and introduce here. So let's right click on it and go to declaration. This one opens up party.h. Now party.h contains the whole list of party members that you can get in the game. When we go to declaration from Dogmeat's party member check, we're taken to this line, which is a define preprocessor directive. In this case, define Dogmeat and party, replacing the text with Dogmeat pointer does not equal 0. And Dogmeat pointer is defined as party member object PID Dogmeat. And PID Dogmeat is also defined as a number, 167775558. PID Dogmeat actually refers to the proto ID number for Dogmeat. And as you can see here, there are 6 stages of proto ID numbers for Dogmeat. This is because he levels up, which is part of a complicated process that I will cover in a separate video. When we create a new party member, we have to have at least one entry here, defining the name as a proto ID number. Well, it's not as strict as that, but I'm just going to duplicate this example so you have a source to follow at home. So first off, we need a define MeatDog and party line, then define MeatDog pointer, and finally we have to have a proto ID number for define PID MeatDog. This isn't too terribly difficult to do, and you don't necessarily have to have these all in the same order. I'm just going to make some copies and some pastes. Copy. I'm just going to go straight to the top here, and I actually have a list of brand new critters for my mod. I'm just going to make some space here. It's not really important where. You just add it in like this. Dogmeat in party. Well, this is going to be MeatDog in party. And we change this to MeatDog pointer. And then we have define Dogmeat pointer right here. Well, this is actually MeatDog pointer. And this is the PID MeatDog. All that's missing is a proto ID for MeatDog. Now you can actually use the proto ID for the critter that you used on the map, the dog critter. And in order to find that, you open the proto manager and you go to your critter section, sorted by name, and we look for dog. And our proto ID right here is 167772225. So we can copy this straight back to our script editor, and we can actually replace this with the number if we want, or let me go ahead and just paste this number so I can remember it later. Or we can go to declaration under PID Dogmeat and then copy that. And we can also alter critter PID.h if you want. It's not necessary though. We can actually put that right here and then change the number to match. Save. Don't forget to rename PID Dogmeat to PID MeatDog. And this is case sensitive, so if you have lowercase here, make sure there's lowercase here. If you want to match the rest of the critter PIDs with all uppercase, make sure that it's also all uppercase here. Save this. Go back to MeatDog. This should disappear in a second. Well, this thing is a little bit buggy, and here's another thing to be aware of. Sometimes the red squiggly lines don't disappear after you've fixed a problem. I'm not sure what the cause is yet, but if you're sure you fixed the problem and you can't see why the line should be marked as such, then close and restart the script editor. This will refresh the error checker and hopefully will clear out any errors that shouldn't be errors. Anyway, so now MeatDog and Party is defined, but there's still a whole bunch of LVAR follow distance problems here. If we take a look at this and select Go To Declaration, we find a few things here. Party member follow dude is if party is waiting equals false and party no follow equals false, then begin. If local variable LVAR follow distance is 0, then begin set follow medium. Now we don't have LVAR follow distance as a local variable, and this seems to be the biggest problem over here because that is definitely what the compiler is yelling about right there. So let's go ahead and create a new local variable. Now, there is a section at the top of this template dedicated to this special type of variable known as LVAR local variables. You don't have to place it here since comments are ignored when compiled, but hey, this seems as good a place as any and keeps things organized. However, there is a special way to declare LVAR local variables, and to see that, let's go back to Dogmeat script and take a look at how LVAR local variables are declared here. Right-click, go to Declaration. LVAR follow distance is written like this. Define LVAR follow distance 10. Now what this does is it uses a predefined variable that gets created in the scripts.lst file. If you take a look at LVARs here, the number of LVARs that this script is allowed to use is actually defined here in the scripts.lst file. Well, we don't have any declared here in meatdog.int. It looks as though we're going to need at least one LVAR follow distance to get this one to work. So let's give it one LVAR. Since it only has one LVAR, that means that LVAR 10 is not really available. If we wanted to give it 10, we could just give it LVAR 10. That should be available. But we only really want to give it one LVAR at this point, because we're only going to work with one LVAR. So we just go ahead and copy this line over to MeatDog, and we just hit Control V. Don't forget to hit save here in the scripts.lst. Before I finish this, there are a couple of things you should know about LVAR local variables. These, like much of programming in C, are numbered starting at 0. So if you have one LVAR open, you assign it the number 0. And if you have multiple LVARs, you start the count at 0, then 1, 2, and so on. Another thing about LVAR local variables, apparently the game uses the first 4 LVARs, so 0 through 3, as part of the dynamic reaction system in dialogue. So if you're making a full dialogue character, then don't use these first 4, and assign any other LVARs to higher numbers, 4+. But for now, I'm just going to use 0 for this LVAR and see where we go from there. Uh-oh, we still have an error. LVAR waiting in factor. Okay, well, let's go take a look at that again. If you look at this for a second, it's pretty clear that the party is waiting macro is what we're looking for. So you go to declaration here, and we find party is waiting, local variable LVAR waiting does not equal 0. Well, that just means we need to have LVAR waiting as well. Uh-oh, looks like now we need 2 local variables declared in our scripts.lst file. So we make 2. Enter, and we save that. So that's 2 of them. Now let's take a look at what else we got. Well, looks like we don't have any more errors in here, but we still have one squiggly line here. Now this squiggly line says expecting a semicolon. Now, this is a pretty common one you'll run into quite a bit, and the reason is because the begins and the ends don't match. This Intellisense Popup is expecting another semicolon because it thinks there's going to be another command coming down. But there isn't, of course. There's just a missing end. Well, all you got to do is count your begins and your ends. I have 2 begins here, and then only 1 end on the way out, which means I need to add 1 more end because the number of begins has to match the number of ends in order to properly close out a procedure. And there you go. You can see the red squiggly line went away, so we can compile this. The only problem is, you'll notice this right away, of course. How do you set MeatDog in your party? Well, that's a little more complicated. First, let's go back to Dogmeat one more time. This time you have to search for a specific command that all party member characters have, party add self. Now here in Dogmeat script, this command is sitting in its own node called node join. But different developers had different styles when creating the scripts for their characters, so other scripts use this command in seemingly random locations. Laddie has it in the map update pproc. Bess stores it in the use skill on pproc. Vic does something similar with node 994. Sulik, Lenny, and Myron all have defines that replace a given string with this command, and these are used in node 800 for Sulik and Lenny and node 232 for Myron. Cassidy and Marcus both use party add self in talk pproc, and Pariah Dog uses it in critter pproc. Where you choose to use this command isn't really important, but I recommend at least being consistent between characters. And for my Meat Dog character, I'm going to create a new procedure so you can see how to call one procedure from within another procedure. You can copy the node join procedure for Dogmeat if you want, minus this line, call node 999, but I'm just going to write the command out myself and rename it join party for clarity. So we write out party add self, and the Intellisense should pop up, and you can just hit tab here to autocomplete it. Let me add the line that calls this join party procedure into the map inner pproc procedure up here. So here I'll add call join party, semicolon. Now the map inner procedure runs each time this critter enters a map, including on game load. And since we're loading this map for our first level, this will place Meat Dog in the player's party immediately on game start. Now to address this red squiggly line that just popped up, you can place the join party procedure anywhere outside of the other procedures, but if you place it after a procedure that calls it, like I've done here, then a red squiggly line will appear under the call because you have to do one more step, which is to scroll up to the procedures list, usually at the top, and add this new procedure to this list. So in my script, it would be procedure join party with a semicolon after it. Now here's why. Because this scripting language is based on C and Pascal, both linear programming languages, the compiler reads the script from top to bottom and remembers variables and procedures in that order. And if the compiler runs into a call for a procedure before it has that procedure in memory, then it'll throw an error and usually point you to the line doing the calling. You can get away with not doing this by placing the new procedure before the command that calls it, but you're probably better off declaring it in the procedures list for readability, if not for at least ease of use. Okay, now that we've got this all set, let's look at the call join party, and that red line is cleared. And now let's go back to the join party node, where this party add self command has an error still. Okay, so what happened here? Undefined symbol LVAR team in factor. Oh my goodness. So that means that party add self uses a third local variable LVAR team. Well, let's go ahead and add that in here too. Just go back to Dogmeat script for a second. Find LVAR team, copy. And we go back up to the top here. Add it in here. Paste. And then we change this to the number 2. And we go back to our list. And since we have 3 local variables, we have to include 3 local variables here. Now we can save this and close it, and this procedure should now be ready. Before we move on, let's right-click and go to Declaration for Party Add Self and take a look at this macro for just a second. Here I want to point out the LVAR local variables used. LVAR follow distance, LVAR waiting, and if you follow this command, store party team, you'll see LVAR team. So if we'd taken the time to go through and explore this macro first, we would have seen all of these variables first and could have accounted for them without having to rely on the Intellisense pop-ups. But hey, now you can solve some of your problems just by reading the Intellisense pop-ups and understanding what they're pointing to. Okay, let's take a look at the rest of the script and see if there are any more bugs. Nope, it's looking okay. Let's go ahead and save it and then compile it. All right, let's load up a game, take a look at Meat Dog, and see if everything's working now. There we go. Now Meat Dog follows you as a party member. That was kind of the overly complicated way of doing it, but creating a full party member with combat settings and dialogue options is a much more complicated task than this that I hope to cover in a future video. Bear in mind that for any commands that you actually want to copy and paste over, that probably the simplest troubleshooting techniques that I've found is to right-click, go to Declaration, and to read what the command script and macro actually do. And as a bonus, if we go ahead and pull out all the party member stuff and go back to here, regenm clear, this may be the correct technical way of doing it. However, you'll notice that none of the other commands we've actually read so far do that. So if we comment out the game time is greater than doWalking, you'll see another bug that is indicative of bad code. So here's glitchy Dogmeat. He's trying to follow you, but he's constantly resetting. He's pointing your direction all the time, but the regenm reset always resets him. And that's because the reset happens every single time there's a critter heartbeat. A heartbeat in this case is basically every time the critter script is called, which is, as I understand it, every game tick. And a tick happens about 10 times a game second, so you can expect Meat Dog's animation to reset 10 times a second with this script. This is not necessarily what we want to have happen. That's why the timer was added here. However, there is actually a much easier solution for this if you just remove regenem clear and recompile again, start our game. And now MeatDog will follow you like we had before. So there are a few things to bear in mind. Regenem clear is supposed to be the correct way to do it. However, when you don't necessarily want it to run regenem clear every heartbeat, the timer prevents that from happening. But if you don't want to run a timer, you don't actually have to run regenem clear. There may be bugs to doing it this way, so if you prefer to do it with a timer and including regenem clear, that's fine. Just bear in mind that there are alternative ways to program each of these things. In fact, if you just removed regenem begin and regenem end, the script should compile and MeatDog should follow you just the same in a single line of code. But you probably shouldn't do this because it makes it incredibly difficult to use items on or steal items from critters using this script because they don't stop moving. Flipping cripes, stop moving, stop moving. At some point, I hope to figure out and make a video covering best practices when creating animate scripts. But for now, I'm going to finish up this video with this. Scripting is one of the most difficult parts of creating a mod for any Fallout game. Fallout 2 is no exception. If you have any programming experience, you'll have a much easier time dealing with many of the problems you'll run into early on. But if you're new to programming, this may not be the easiest language to get into. But you'll see the results of your work right away. And following examples from other source codes allows you to dip your toes in without having to dedicate a month of your life to learning a full programming language. But let me tell you, taking a month to learn the C language or Pascal sure does help. I've tried to cover the basics of scripting here, but I've glossed over a lot of the details in order to shorten the video, and it still ended up being 40 minutes. Stuff like, variable type is handled by the compiler, so you don't have to set a type for every variable, which has advantages and disadvantages. The colon equals operator is the Pascal version of the equals operator in other languages, which is just the assignment operator. For that matter, the begin and end statements are also from Pascal. Vanilla scripts didn't use arrays, but the Sfall mod has added arrays into the language, and a whole bunch of other stuff that I couldn't possibly cover in a single video. Which is to say, this is a complicated topic. And because it's so complicated, I'll be placing in the description every link I've found to every wiki article, forum post, residence, random comment, 10 house, outhouse, GitHub, and just whatever I've run across the internet that can help explain Fallout 2's scripting language. It'll be a bit before I make another scripting tutorial. Turns out these videos require a lot more work than I originally thought. But until then, I'll be reviewing a lot of mods, and I hope to cover your mod someday. For now, let's watch as Bob and MeatDog walk off together into the sunset. Meow.